Successful conception during the natural cycle depends on the delicate interplay among hormones, which maximize embryo quality and create a favorable endometrial environment for embryo implantation. Two such gonadotropin hormones are luteinizing hormone, or LH, and follicle-stimulating hormone, or FSH. These hormones are involved in the two-cell, two-gonadotropin theory of estrogen biosynthesis. The two cells involved in this theory are LH-regulated theca cells and FSH-regulated granulosa cells. Estrogen biosynthesis begins when LH binds to its receptor on theca cells with the conversion of cholesterol into progestins. This then triggers a signaling cascade which drives the conversion of progestins to androgens via enzymes, including 17-alpha hydroxylase. On granulosa cells, FSH binds to and activates its receptor. This triggers aromatase's conversion of androgens to estrogen. Estrogen stimulates endometrium proliferation and blood vessel formation, which play a critical role in implantation. The two-cell, two-gonadotropin theory highlights the complexity and delicate balance that exists between different hormones which promote embryo implantation as well as follicular development. Because FSH has the potential for multiple follicular recruitment, various forms of exogenous FSH have been developed for fertility treatment. Use of exogenous FSH alone has been shown to promote the development of multiple follicles during ovarian stimulation. It is thought that this is mediated through its interaction with its receptor on the surface of granulosa cells. However, controlled ovarian stimulation with FSH alone has been shown to result in lower levels of estrogen concentrations at the conclusion of the stimulation period. According to the two-cell, two-gonadotropin theory, FSH is needed in combination with LH to produce adequate estrogen levels. When high levels of FSH and low levels of LH are present, serum progesterone levels increase due to the lack of LH-induced conversion of pregnenolone into androgens. Elevated progesterone levels can result in a change in normal synchrony between embryo and endometrium endocrine profiles. The endocrine asynchrony generated by lower estrogen concentrations relative to increased progesterone concentrations may reduce embryo development, endometrium receptivity, and implantation. HP-HMG is a highly purified monotropin formulation that delivers both LH and FSH in a 1-to-1 ratio. In HP-HMG, the principal activity of LH is provided by human chorionic gonadotropin, or HCG. Both LH and HCG have similar structures, meaning that they have similar biological functions. However, HCG is more potent because of its higher binding affinity and a longer circulatory half-life compared with endogenous LH. This increased potency and duration of action distinguishes endogenous LH from HCG. It is thought that the HCG-driven LH activity found within HP-HMG offsets the rise in progesterone levels by stimulating theca cells to convert progestins to androgens, which are then metabolized to estrogens in granulosa cells through its FSH activity. HP-HMG maintains the balance of FSH and LH activity over FSH treatment alone, while preventing a rise in progesterone levels. This balance is important for proper steroidal genesis, endometrial receptivity, and implantation. As you can see, the three different environments result in different rates of estrogen biosynthesis. Prescribing information is available from a Ferring representative.